The year is 1935. In Stockholm, a prestigious ceremony is underway, celebrating the pinnacle of scientific achievement. The Nobel Prize in Physics is awarded to James Chadwick for his discovery of the neutron. It is a momentous occasion, marking a significant leap in our understanding of atomic structure. Yet, a shadow falls across this triumph, a detail so small it might be missed by all but the most meticulous observer. The following year, 1936, the Nobel Prize in Chemistry is bestowed upon Otto Warburg for his discovery of the nature and mode of action of respiratory enzymes. His work illuminated fundamental processes of cellular respiration, and in 1948, the Nobel Prize in Physics is again awarded, this time to Patrick Blackett for his work on the magnetic fields of cosmic rays. 3 separate prizes, 3 distinct fields, yet bound by an unseen thread. This thread is not one of collaboration, but of erasure. Within the official archives, a peculiar anomaly appears. On the documentation, the citations, and the records pertaining to these 3 distinct Nobel laureates, a name has been systematically removed. It is not an omission due to oversight, but a deliberate act of excision, leaving behind faint indentations and smudged ink where a significant contributor once stood. The historical context of the early 20th century was one of rapid scientific advancement, particularly in the burgeoning fields of quantum mechanics and nuclear physics. Universities and research institutions, like the Kaiser Wilhelm Institutes in Berlin, became crucibles for groundbreaking ideas. Funding was often tied to national prestige, and the pursuit of pure science was intertwined with complex geopolitical currents. Within these institutions, a particular culture of scientific inquiry prevailed. It was a world dominated by a handful of prominent figures, often men of considerable ego and influence. While collaboration was essential, the hierarchy was steep, and credit was not always distributed equitably. The intellectual landscape was fertile, but the soil was occasionally poisoned by ambition and prejudice. The name that was systematically scratched out belongs to a physicist and chemist named Ida Noddack. Born in Paderborn, Germany in 1896, Noddack was a prodigy. She earned her doctorate from the University of Freiburg in 1921, one of only a few women to achieve such a distinction in the male-dominated scientific world of the era. Noddack worked alongside her husband, Walter Tach, and Otto Berg, contributing significantly to the research conducted at the Kaiser Wilhelm Institute. Her early work involved the isolation of rare earth elements, a technically demanding process requiring immense precision and chemical insight. Her meticulous laboratory skills were widely recognized by her peers, even if her name did not always appear prominently on the final publications. Her most notable contributions, the ones that would later be recognized by Nobel committees, involved fundamental discoveries in atomic mass and nuclear fission. In 1934, Noddack published a paper challenging Enrico Fermi's interpretation of the results of bombarding uranium with neutrons. Fermi believed he had created transuranic elements, but Noddack proposed a far more radical and accurate explanation. Noddack theorized that the uranium nucleus had split into smaller fragments, a concept she termed nuclear fission. This was a revolutionary idea, preceding the experimental confirmation by Otto Hahn and Fritz Strassmann by several years. Her insight was so profound that it was initially dismissed by the scientific community, deemed too unconventional to be true. Her other major contribution, and the one directly linked to Chadwick's Nobel Prize, was her co-discovery of the element rhenium. In 1925, after years of arduous work processing tons of gadolinite ore, Ida Noddack, Walter Tach, and Otto Berg announced the discovery of element 75. They proposed the name rhenium after the Rhine River. The isolation of rhenium was an extraordinary feat of chemical separation. Noddack's analytical techniques and perseverance were crucial. However, the Nobel Prize for this discovery, or rather for its implications and further study, would eventually be awarded to others, notably James Chadwick, whose work on subatomic particles was seen as a direct consequence of understanding elements like rhenium. Furthermore, Noddack's work on the oxidation states of metals and their role in biological processes was foundational. Her research into the role of trace elements in cellular function was advanced for its time. This research laid groundwork for understanding biological catalysts, a field that would later earn Otto Warburg his Nobel Prize for work on respiratory enzymes. The deliberate removal of Ida Noddack's name from the records surrounding these Nobel Prizes is not a simple historical oversight. It reflects a systemic bias, a subtle but pervasive sexism that often relegated women scientists to the background. Their contributions, however significant, were frequently absorbed into the work of their male colleagues or attributed elsewhere, especially if the women were not the primary institute heads. The reasons for the erasure are complex and likely multifaceted. Noddack's radical theories, her outspoken nature, and her gender may have all contributed to her marginalization. In a scientific establishment eager to cement its heroes, her name became an inconvenient truth, a reminder of a meritocracy that was, in reality, deeply flawed and exclusionary. The legacy of Ida Noddack is a stark reminder of the hidden figures in scientific history. Her concept of nuclear fission was years ahead of its time, and her discovery of rhenium was a monumental achievement in analytical chemistry. These were not minor footnotes, but significant advancements that reshaped our understanding of the universe. The implications of such erasure extend beyond individual recognition. They question the very integrity of scientific history and the narratives we choose to preserve. How many other brilliant minds have been similarly sidelined, their discoveries appropriated or simply forgotten, leaving us with an incomplete picture of scientific progress? The evidence of this erasure persists in the physical records, the faint indentations, the smudged ink, the empty spaces where a name should be. These are not merely historical curiosities, they are silent testimonies to a quiet injustice, a deliberate attempt to rewrite scientific history by removing a key protagonist. While official recognition eluded Ida Noddack in the highest echelons, her scientific contributions did not vanish entirely. The scientific community eventually acknowledged the validity of her ideas, and her work on rhenium is now standard. Her story, however, serves as a crucial archival footnote, a case study in the subtle ways prejudice can shape historical narratives. Her life's work, though marred by the deliberate attempts to obscure her role, ultimately speaks for itself. The faint marks on old documents are a reminder that history is not always as it is presented, and that sometimes the most important discoveries are found not in the spotlight, but in the margins, waiting to be unearthed. The archive guards its secrets carefully, but it also preserves the traces of what has been lost. By examining these faint indentations and subtle omissions, we can begin to reconstruct a more complete and more honest history of scientific endeavor. The story of Ida Noddack is one such reconstruction,